All right, good morning, everyone. This is Dr. Jonathan Kleinjohn here at South Dakota State University, and I'd like to welcome you to the first day of our 2024 Crop Hour series. This week we'll be talking about corn, and our first speaker is Dr. Adam Varenhorst, Assistant Professor and Extension Entomologist. He's going to be discussing corn rootworms, how bad were they in 2023, and what management options exist. So Adam, I see your presentation up and going, so here we go.
Well, good morning, everyone, and thanks for the introduction, John. So how bad were corn rootworms? Well, it's one of those things it's kind of tough to say for the entire state without going around to every cornfield out there. But we do have some idea based on what we did for research and also the amount of reports we had for rootworms in 2023. So if you've ever scouted out in a cornfield or you have a garden with any flowers that have yellow on them, or sunflowers specifically, you probably have come across northern corn rootworms. These beetles are fairly small. They're green in color. However, in July, sometimes towards the end of July, we can observe some of the adults that are almost a yellow color. So why the big variation? Well, a lot of that has to do with the fact that the adults that are more of a yellow color have just emerged. So you've observed them right as they're emerging from the soil, and they haven't actually fed on anything yet. And as a result, they haven't taken up any chlorophyll because these adults do feed on leaves. And so that's part of it. So the larvae, though, are what we really care about for corn rootworms. The adults of both species that we're going to talk about today can cause economic injury by feeding on the silks. However, that's not as common as the larvae feeding on the corn roots. So the other species that we care about in South Dakota is the western corn rootworm. And these adults are going to be a little bit larger than the northern corn rootworms. And as you can tell, they're also going to vary quite a bit in color. So they are a yellow color, and then they have variation in the pattern. So sometimes it's 3 black stripes. Sometimes those stripes begin to blur, and sometimes they're blurred to a point where it looks like just a patch of black on the yellow abdomen. And so those are all still, though, western corn rootworm adults, but there can be variation, which, as we all know, makes it a little bit trickier for identification. And just like the northern corn rootworms, it's really the larvae we care about unless we have huge populations of the adults, and then sometimes they need to be managed as well. And so I apologize, this picture was with my cell phone this summer, but just wanted to drive home that point. When you have a severe infestation of corn rootworms, sometimes you don't even need to really determine how bad it's going to be. You go out and your corn in July is starting to lean over a little bit after rain or a little bit of wind. And if the populations are really bad, like they were for this particular plant, you can just pull it up with your hands. You don't need to have a shovel along, which is pretty unusual for corn in July. And this one just shocked us because as we pulled it out, you can actually see rootworm larvae. So here's one right here. There were actually some that were falling out of the root tissue as I pulled it up. And so those rootworm larvae will be present. This was early July, and the adults started emerging about a week and a half later. But if you go out too early to scout for rootworms, depending on what you want to see, you're going to actually still be finding the larvae, and we'll talk about that in a second. So the life cycle for both species is very similar. As you can see on this picture, pretty much overlap. And there's likely some variation for the two species. However, it's very close. And one of the things I like to point out is, seasonalities, everything changes from year to year because we don't always have, open Aprils in terms of no snow cover. Sometimes we get a major snowfall in April, and that's going to affect when these adults do eventually come out because that will cool things off. As a rule of thumb, though, we'll start with the adults. They typically emerge sometime in the middle to late July. And once those adults start to emerge, that's when we can start scouting for our problems. And the reason for that is the larvae are done feeding. So the adults emerge in mid-July of both species, and they're going to seek out pretty much anything they can find at first. They're going to be hungry. The northern corn rootworms, a lot of times we'll find them in soybean fields, or as I'd already mentioned, sometimes they migrate to yellow flowers. They love yellow flowers, especially sunflowers. The western corn rootworms, a lot of times will stick around in that cornfield more, just a general observation. But they'll be active until pretty much the first hard frost, which I have noted here, just based on the last few years, tends to be later October. During the summer, the females will begin laying eggs shortly after they emerge. They mate, they've had food, they'll start laying eggs. And so that, again, will also vary depending on when they emerged. So the later emergence, later egg laying begins. But these adults in South Dakota will always be laying the eggs into the cornfield or wherever they're at. And so as they begin laying those eggs into the cornfields, eggs are going to stay in the soil, and the eggs will actually overwinter. And so I get a lot of questions each year. Oh, we had a really cold winter. What did that do to our corn rootworm populations? Well, because they're eggs are extremely hardy in insects. They're in the soil, so they have kind of a protection layer. And so it has to get really cold. The soil needs to be without snow cover. It needs to get really cold, and we need that cold to go down quite a ways to reach the eggs. As a result of that, we typically don't see a lot of egg mortality or egg death during the winter. The eggs will stay in the soil until sometime when it finally gets to the right conditions, it's warmed up enough, and then the larvae hatch. Now, if you notice, the larvae are hatching sometime in early to mid-June. And as a result of that, we typically plant corn in May, so the corn's already there. So larvae are hatching, they're hatching in a cornfield or what had corn last year, and they're going to be seeking out corn roots. And they feed from about mid to early June until the adults start to emerge, so whenever that occurs. They do have a period where they pupate once they've reached their final larva stage, and that can vary again based on if they were able to successfully feed rapidly. But all of that varies, and so there's always a little bit, as you can see here, it's not a perfect picture, there's a lot of overlap. But the idea here is that we do know when these guys start to show up, the adults, and then we know that it's time to start scouting. So how do we scout for corn rootworms? Well, there's two main methods that we recommend. The first, I did a lot of this last year because Billy Fuller, who was our corn rootworm entomologist on campus, retired last June. And as a result of that, I decided to pick up the research, and we dug a lot of roots. So larva injury, typically, we're looking sometime in July or August. How do you do it? You have to dig cord roots. You dig those roots up, but that's not it, because if you dug a corn root up, you get a root ball. The root ball doesn't show you much, so you have to wash the roots. What we do on campus is we soak them. It's extremely high tech, but it's very effective. So we soak the roots for about an hour, somewhere in there, depending on how much we have to process that day. Sometimes it's less. And then what we do to speed up, because if you soak them longer, it's less work for you down the road, but we actually stand over the tank and just splash the roots until they get most of the dirt off. And then because we're looking for exact amounts of damage, we use pressure washers that have a zip tie so that the gun's on nonstop. And then we have people that, as you can see, they're dressed up to try to avoid getting completely soaked, but they spin the roots in the pressure washer stream so that it essentially cleans all of the rest of the dirt off. And then I doubt he's on today, but what I do is I hire somebody with a lot of experience to rake corn roots, but you examine nodes 4, 5, 6 for damage. One of the things that Brad was discussing with me this year is that sometimes there's accidental removals of nodes when you're doing the digging. So you do have to be very careful to not dig really close to the roots. You have to dig out a little bit, because otherwise you're going to accidentally cause a little bit of damage to nodes maybe 6 and 5, because those are the ones closer to the soil surface. And the other thing is if you're too aggressive in washing the roots off, when those big pieces of dirt are coming off, if they're not soaked really well, you're artificially making the root damage look worse. So there is a definite process to it. But once you get there, you're looking for that damage. A lot of times you look for discoloration. or if the roots are actually pruned back. And so this is a picture that I think really shows the stark difference between very little damage, so a good healthy root for the most part. There's a little bit of feeding on it, compared to one where there's definitely a corn rootworm problem. If your field looks like this, you probably don't have a ton to worry about. If your field looks like this, it's time to reconsider what you're doing for management. So once you've gotten your roots all clean, I said you need to rate them, but there's a scale you use. So it's not just looking and seeing if the roots are discolored or if there's maybe a little bit of feeding. But on the node injury scale, what we want to always see is a rating of 0. So there's no apparent feeding. There's no discoloration, which is the scarring caused by the feeding. However, most of the time we don't have that luck. Even if we use a really good treatment, there's going to be a little bit of feeding. So a node injury scale from 1 to 1.9 means that at least one full node, or essentially the composition of one full node, is destroyed to within 1.5 inches of stock. So I said pruning. So a lot of times they'll feed on the roots, and you can see here, this is what that pruning looks like. So within 1.5 inches of the stalk. If you have somewhere in that 1 to 1.9 range of damage, you're probably going to see some lodging and goosenecking in the field. Those plants have become weaker. They're not getting the nutrient flow that they would if the root system was completely healthy. And one of the things I like to bring up, because most of us care most about the yield, if you have a lot of lodging, you'll care about that when harvest comes around. But what's the yield impact of a rating of a 1 to 1.9? Well, somewhere in the ballpark of 15% yield loss. And so just by having that one node destroyed to within 1.5 inches, you're already looking at about 15% yield loss. You can imagine a rating of 2, you're looking at 2 or more nodes gone for rating of 3. So for a 2, you're looking at least 2 full nodes destroyed. A rating of 2 would mean 30% yield loss, because each rating just increases the yield loss by 15%. If you get to a rating of 3, you have a really severe feeding. And this sometimes happens as a sign of resistance developing towards the BT products, the traits that are being used in the field. The symptoms here: severe lodging and goosenecking. The field is pretty much going to go flat when you get any wind. Another thing is when you're out in that field, there are going to be tons of adults crawling around on those corn plants. Even, I will note that even at this point, you will see at a rating of 1, you will notice the amount of rootworms out there. But as I mentioned, a rating of 3, you're looking at about 45% yield loss. And sometimes that can be worse, because you can imagine that's just due to the feeding. That's the reduction in ear fill and size. However, you can imagine if you have a lot of lodging, you're going to have additional yield loss, because it's really hard to pick up an entire field that's gone flat. So that was scouting method number 1. The second scouting method is using yellow sticky cards. You put the cards out. I do notice I need to update this, as with everything, post-COVID-19 pandemic, everything's gone up in price. So these are more expensive now. But we typically recommend putting the cards out. We typically try to hit 4 corners of the field. So go in a little bit, put the sticky cards, so you're kind of getting a picture of the entire field for the pressure. But you can replace these cards on a weekly basis. You count the number of adult rootworms on each card. And notice I don't say you count each species, you just count total rootworms. Anytime you have 2 or more adults on the card, you're at the threshold for that field, meaning that you need to do something else the next time you plant corn. So if you had a BT, you need to switch to maybe a soil insecticide. If you had conventional corn with nothing, you might want to consider putting in furrow, or have a seed treatment with an in furrow, or using a BT hybrid. So just whatever you were doing, you need to add something to it to try to make it work better, or switch completely. One of the other things I always like to point out with these sticky cards is you want to make sure you have your cell phone, take a GPS coordinates for each one of these cards, because we've had it in the past where people put these out and then they come around when they're harvesting, they go, oh yeah, I put cards out, because they either couldn't find the card when they went back out, or they kind of forgot about it. But Sample on a weekly basis if you use them, and make sure you can find them again when you're out in that field. And so this is why we care so much about managing rootworms. So these are some pictures from a colleague of mine that I worked with at Iowa State when I was down there. He did a lot of research on corn rootworms for his degrees. And these are some really good pictures, not good in terms of the damage to the corn, but good to indicate how bad rootworm pressure can be and what it can do to a field. So when you have severe pressure, this is what that lodging can look like, and it's not even 100% yet. The other thing is, because you're having the root feeding, so they're reducing nutrient flow and water flow, you end up with ears that just never fill out. They're really sad. And so the big issue with rootworms that we have is once the corn is in the ground, the seed's been planted, it's in the ground, there's nothing we can do for those larvae. We can't get insecticides down to them. So we either have to have the BT put insecticides in the furrow at plant. Seed treatments can have some impact on the corn rootworm populations, but one of the big things is once you're planting, you're going to have to just weather the storm, and then the following time you plant corn, whether it's the next year or if you have a rotation, you have to do something different. Now, I had mentioned we don't typically worry about the adults, but if the adults beetles of either species, typically it's whatever species is most prevalent in the field, begin feeding on silks or clipping silks, that's when we care. So we kind of do a really quick change, and we go from saying, well, there's a few out there. If you start noticing silks being clipped, then it's time to do a foliar insecticide. Typically, when we say doing this, we mean using an aerial application. Because it's time to essentially, a lot of times it's called beetle bombing. It's time to treat those adults and get the populations down. But it's not recommended unless you either have the silk clipping or you have just insanely large populations of beetles out in the field. And so what did the populations look like for 2023? One of the things I want to look at for just the research we did was the research sites we have for what we work on testing different products. We have a site near Bruce, Bryant, Coleman, and Cavour. And one of the things I want to point out is we haven't done research at the Bruce site yet. And the other thing is this hasn't been, I don't know exactly how long each of these sites, I can't remember, have been corn on corn. But the Bruce site hasn't been corn on corn for as long of a period of time. And the reason I bring that up is you'll notice this is total northern corn rootworms. This is total western corn rootworms. We're not quite at a 50-50 ratio for the two species, but there are a lot more northern corn rootworms at the Bruce site. These sites have been corn on corn for a much longer time. And as you can see, the longer you have corn on corn with heavy rootworm pressure, eventually the northern corn rootworms kind of disappear. The populations really go down because this is weekly for 2 months of sampling. So, we are only, after about 6 weeks of sampling, we only had 85 northern corn rootworms versus 1,875 western corn rootworms at the Bryant site, and very similar for Coleman, where we had almost 2,000 western corn rootworms and 140 northern corn rootworms. And then Cavour, again, almost 2,000 western corn rootworms, very few northern. And so the western corn rootworms do seem like eventually they kind of push out the northern corn rootworms. Well, why does that matter? Well, in South Dakota, we have northern corn rootworms that have extended diapause. And that means that the females will lay the eggs into the soil. And even if you have a crop rotation, it might not matter because those eggs have the ability to just persist in the soil. They don't have to hatch the next year. They can hatch in a couple years down the road. And so it's kind of interesting, though, that we have that variant, but the longer you have corn on corn, it seems like the fewer northern corn rootworms you have. And maybe that extended diapause isn't quite as much of a concern. Now, if you guys are familiar, there's also a soybean variant of western corn rootworm they found in Illinois quite a few years ago. And to our knowledge, we still do not have that variant in South Dakota. So it's going to have to move through the entire state of Iowa before it gets here. And as far as we're aware, it hasn't made it that far into Iowa yet. So we'll keep our eyes open for that, but so far we're not seeing it. Now, there's a lot of information on here on this table, but this is the test for the infertils we tested here in 2023. This is at our Bryant site. So I mentioned we aren't doing research yet at the Bruce site, but at the Bryant site, what I want to point out is we're still scratching our heads on this one. So the UTC is our untreated corn. This is all conventional corn with nothing on it, all the same hybrid. And when we look at our yield for our untreated, it was 202 bushels, almost 203, and it had a root rating of 1.2. So we should have seen yield loss for those plots. And what we noticed, though, is it yielded better than all of our treatments. So we aren't quite sure what happened there. We're still trying to dig through that data to figure out how this happened, because everything else, if we just look at the root rating for all of the treatments work pretty well. I will point out that the Aztec down here and the Force, these are the granulars. The rest of these are liquids. And, just looking for the most part, the granulars still can do pretty good. We use smart boxes for those. The rest of these we just applied either as the liquid or a couple of these are foam from FMC. So we use the Thrive system for that. But for the most part, if you look at our Bryant side, it looks like it's better off. You're better off just planting your corn and rolling the dice. But we still think there's probably something got messed up here. But what did everything else look like? Well, for our Cavor site, it was a little bit different. Our untreated control wasn't the best treatment. And if we go down, we actually see that the capture LFR, the Ethos XB, the Ethos XB Elite, these are applied as foam, as well as the capture LFR there. But they did well. Our two granulars didn't do as well in terms of the yield, but they did have low ratings. So we had a 1.5 in the untreated control. Everything else was way below that. We didn't reach a 1 with any of our treatments. But again, yield was pretty variable. And some of that might be due to the fact that we do have to remember these are small plots, and there's always a little bit more variability with those. Our Coleman site looked very similar to Cavor. We had a pretty good yield at 141 with the untreated control, but a 1.7 root rating. Everything else had way lower root ratings. And then if we look at the yield, everything yielded pretty similar. So we couldn't actually tease anything apart with statistics at the Coleman site, but just numerically, our granulars did do the best at Coleman. So it's kind of hard to say what treatments did the best there, but definitely evidence that those in-furrow treatments can still provide us protection. So what about BT? Well, there are currently a combination or alone these traits available. You will not find this is the new RNAi rootworm technology. You won't find that by itself. It's always going to be with something. So we have Cry3BB1, mCry3A, eCry3.1, AB. These are all just different BTs, so they work a little bit differently. Very similar, but a little bit different. Cry3435AB1, which apparently they've recently changed the name. So if you're looking at your seed catalog and you come across this, it's still what used to be referred to as Cry3435. And then Cry3BB1 plus and there's also more variations with that RNAi, so the DVSNF7. One of the things we've been recommending for quite a few years, based on some research, North Dakota researchers came down, collected some rootworm from South Dakota a few years ago, and they did tests, and they determined that we do have resistance, and other states have resistance to Cry3BB1, Cry3435AB1, and also eCry3.1AB. And so we typically recommend avoiding using these as single genes. And if possible, we say try not to use pyramids, so more than one of these genes with these three. The problem is as we'll see in a second, that's not possible. The other thing we recommend avoiding is using BT plus soil applied insecticides. And it's not because it doesn't work. It's more of an issue that we either want to put the selection pressure on the BT or the soil applied insecticides. The other issue is, if you remember, nowadays it's all refuge in a bag. But if you're using BT, you need to have a refuge. If you're using BT plus soil applied insecticides, you're killing most of the adults out in the field. The only ones that would be emerging are the ones that are resistant to the BT as well as the insecticide that was used. And so we want to try to avoid that. And that's why we say either use the BT or the soil applied insecticides. Don't use the combination. Here are the different trait combinations that are currently commercially available. Now, remember I said to avoid some of those in single or a combination. Well, if you follow my recommendation, unfortunately, nothing's going to be really useful for you. We'd say that we'll avoid all of it. Well, let's go back. Chances are, if you have one issue, maybe you don't have issues to all three. The other issue, though, is I know you're all aware of, the more traits you have, the more expensive your tech fees are for that bag of corn. But if you were trying to choose what might work the best going forward, if you've had issues in the past, obviously, maybe trying that new RNAi technology would be an option. However, I'm not endorsing it. I'm just recommending that completely stay away from these genes that are by themselves. The Cry35AB1 with the mCry3A, we haven't had issues with that in South Dakota, as well as the eCry3.1AB. But if you've had issues with these in the past, you're really just using this, and it's not going to work great. Same with these ones with the new RNAi. So what other options do we have for crop management? Well, always crop rotations. The more you rotate away from corn, short of having that extended diapause northern corn rootworm, crop rotations will help because you're going to reduce the amount of eggs in that field and hopefully reduce the amount of pressure you have. If you have mild to moderate pressure, BT hybrids should be effective for you. And I say that because unless you've had corn on corn for numerous years and already have issues with the BT, if you're doing a rotation, you know that you have rootworms occasionally, you should still be able to get away with using the BT. But I would still recommend using more than one gene. And the other thing is if you have very high pressure, it's probably time to look at doing some of those in-furrow treatments without the BT, and then eventually go back to the BT if you're doing corn on corn. So the work here, a lot of it was research from companies, but I also like to thank the USDA for the grant that helped fund some of the work we did this summer. Here's some information for you all from, and then I just throw this up here. So if you need to get a hold of me, I see there are a few questions, but if you need to get a hold of me, if you saw the talk last year, I moved a floor down in the building. My office phone number's a good place to reach me, or you can shoot me an email. Either way, I'll try to get back to you as fast as possible. But I will go ahead and take a look quick at these questions. Where can I buy the rootworm sticky paper? So those sticky cards, my lab typically orders them from Gimplers because they tend to be the most reasonable price-wise, and a lot of times you can buy them in bulk. You're looking for its PHE. E is in trying to think of a good E is in excited, ROCON. So Farrakhan. So the yellow sticky cards, they're the Farrakhan ones, or the Tracy, TRECE. Those are the two that are most obvious. But they're going to be somewhere between $2.50 to $3 probably for this next year. Our anonymous attendee, if you are interested, shoot me an email. There is a program that Iowa State is kind of the leader on, but we participate in, and farmers are able to volunteer for that program, and they send you the sticky cards for free. The catch is you have to go scout them and then report the numbers back. So that it's essentially we're surveying rootworms throughout as many states as possible to get an idea of what populations look like. But I'd be happy to share that information with you. Gary Erickson, why the difference in capture yields? Chances are, Gary, I don't remember which slide that was, but remember we did have just the liquid plus we had the foam, and chances are that was probably a little bit, but what wasn't shown on those tables because I ran out of room on the slides. is there's a lot of variation within each of those yields, and so chances are that they look a little different numerically, but ultimately, if we look at the variation, they overlap. But chances are that that was what was going on there. So otherwise, it is 10:30. I'll turn things back over.
Okay, with that, I'll introduce the next speaker. Maddie, if you'd want to start sharing your presentation. Our next talk is Assistant Professor and Extension Plant Pathology Specialist, Dr. Madalyn Shires, and she's going to be talking today about corn tar spot and bacterial leaf speak management. So, Maddie, go ahead and take it away.
All right. We being me and Connie Strunk, who is our Extension Plant Pathology Field Specialist, are excited to be talking and sharing, talking about and sharing information on some corn diseases. All right. My screen will go forward. That is. There we go. Okay. So several of you, if you've worked in corn here in South Dakota or in surrounding states, have probably heard of tar spot. This is a fungal disease that began emerging in the United States in around 2015. Here in South Dakota, we first saw tar spot in 2022. We found it down in the 6 southeast counties, and I'll have those listed out in a slide in a minute. The picture on the right side of the screen shows the different counties that tar spot has been confirmed in. So those are the lighter gray counties. The picture on the left is an extreme example of tar spot. I was able to go on a scouting trip this year to go see tar spot in Missouri, Kansas, and Nebraska. So I got some pictures to be able to share for talks. Tar spot. Again, it's a fungal disease caused by the fungus Phyllochora matus. The tar spot fungus has been shown to survive on corn stubble in all states that tar spot has been found in. The development of disease is favored by warm temperatures and high humidity. Here in South Dakota and in most other states, it does seem to be developing in corn later in the season, which is mid to late grain fill. However, an exception to that is in Missouri this year, which is, again, where most of the pictures you're seeing on these PowerPoints came from. They actually began seeing it in June. So at the start of grain fill, they began seeing tons and tons of spots on leaves and began fungicide applications to try to slow the development of disease. So that, though, with Missouri being further south than us and having more rainfall, we probably won't ever see that here in South Dakota, but it is an example of what it can be like in other states. So 2022 tar spot in South Dakota. Again, we found it in 6 southeast counties. We found these disease spots in October 2022. As Connie and I will both tell you, we would find the spot on a Tuesday and the cornfield was harvested on a Wednesday or a Thursday. So it was really hard to find any more than what we did, and it definitely did not have any impact on yields, as the overall incidence was extremely low in all the fields. We would find 1 to 2 lesions per leaf and 8 or less leaves affected on most plants, and most of those leaves were lower in the canopy. The counties that were confirmed with tar spot are listed in severity. So Union County had the most spots found on leaves and fields, and McCook had the least. These are some examples of what we found in Clay County and Yankton County. Again, you can see on these pictures the small black spots that almost look like black paint has been thrown on the leaf. Those are the spots that we would find. So if you think back to the earlier slides where there's just black spots all over the leaf, we were very, very different from that and much lower disease levels. One way to identify tar spot is when you see these black spots on leaves, try to wipe them off, maybe by licking your thumb or with a little bit of water. If the spot does not come off, then it could be tar spot. We did receive several samples this year that actually ended up being insect frass or another fungal disease. We are happy to receive those samples, so please don't stop sending them, but there are a few ways that you can determine if you might be dealing with tar spot in the field before sending it to us. So 2023 tar spot. We only found tar spot in 3 South Dakota counties. The overall incidence, again, was extremely low. And it was similar in the infection pattern, 1 or 2 lesions per leaf, 8 or less leaves affected on most plants. However, the volume of disease symptoms was lower. The counties, again, that we found tar spot in were Union, Clay, and Yankton. We also scouted 15 additional counties and further to the west and to the north looking for tar spot and did not find it. And we scouted from July through the middle of October. So we are pretty confident that it was just very low incidence in 2023. So in other states, they are actually able to determine that tar spot does impact yield. They've made a measure that over 60 bushels per acre of yield loss occurs from severe tar spot infections, like what you can see on the left side of the screen. Again, here in South Dakota, our levels are extremely low. They've also determined that dryland, non-irrigated type corn is less likely to be affected as this fungus does need moisture to begin infection. One of the things that I wanted to point out on the picture that you can see on the left is actually the middle of the screen. I don't know if y'all can see my mouse, but this is called a fisheye spot symptom. It's that brown ring that is around the black spot. That is a hallmark symptom that they're starting to see in the southern states and the eastern states that have tar spot. We did not see that here in South Dakota with any symptoms that we found. We're not exactly sure why that's occurring, but it is something that we are exploring. So management of tar spot here in South Dakota specifically, first step is to not panic. The disease severity that we found over the last 2 years does not warrant spraying a fungicide. We are recommending that if you live in those far southeast counties, you consider looking at corn hybrids that might show tolerance to tar spot. Again, it's probably not a rush, but it is something to start considering in future management plans. There are some fungicides, which I'll be talking about here in a minute, that can be utilized when conditions warrant. However, we've not had enough disease or conducive weather conditions for tar spot to need to have a fungicide application made. So one of the things that's been developed with the tar spot working group is this app here that you can see on your screen. It's called Tar Spotter. It's free in app stores. And it is actually a tracking app to help you determine what your disease risk is and if fungicide applications should be made. So the next few slides are actually information that was prepared by my graduate student, Sierra Kataska, who is working on tar spot and BLS. Once you open the app, on the left side of the screen, you can see the home page of the app, and it has options of a new field, field list, or help and information. The middle picture is what you will see whenever you click add a new field. You can put in your field name. It can also geotag your location, and you can save all of that information. On the far right side, you can actually see some of the fields that we added in 2023 just to kind of track what disease development was and what the disease pressure was. And all of these locations on the far right are just random cities and towns that we picked. They're not actually any fields that we were in. So once you've added your field, I'll go back here. You can see at the bottom on the right-hand side that we have a field named SDSU. Once you've added that field, you can look at some different information to allow that disease model to forecast your disease pressure. They recommend an action threshold of 35%. That you may have to adapt that yourself depending upon what your personal preference is for an action threshold of spray or don't spray. As you go down through the next few options, if you've not applied fungicide in the last 14 days and you're within the growth stages of V10 to R3, it will allow you to run the forecast. So once you've clicked through all of that, you can see the next picture is actually what the forecast is. So we were able to see that if we were seeing tar spot in the field, that our risk of it spreading and becoming a problem was extremely high. And another cool thing that we enjoyed in the app is that you could actually see the field history. So you could see how your risk levels changed every day or every week, however often you ran that for the field. You can also see a map of all of your fields and what the risk levels are for that day, which was also interesting to kind of see how that changed. The final thing that you can do from the app is on the right side of the screen, and you can actually export your records in Excel. So if that's something that you are interested in charting or watching or whatever, there's a way to remove them from the app onto a more workable platform like on your computer. Now I'm going to share some slides. If you watched corn crop hour last year, you did see a version of these presented by Tamara Jackson. So I'm just going to show these again. These slides are courtesy of Darcy Talenko at Purdue University. One of the most interesting pictures to show about tar spot is this one that you can see on the screen. And it's the rapid development of tar spot, how the plants looked great, which is on the left picture. And 13 days later, the right picture is what the plants looked like. And that was with rapid development of tar spot. So whenever this disease does get going in a field, it is extremely detrimental to your plants. There's been some uniform fungicide trials done on tar spot in Illinois, Indiana, Michigan, and Wisconsin, looking at different fungicides and their efficacies, how often they should be applied. So this is one that was done. You can see the different fungicides that were trialed at the bottom of the table, or of the graph, I'm so sorry. And they found that the ones on the far right-hand side were more effective. So those are the ones labeled as E, were more effective at controlling disease severity than the ones that are to the far left. This is another trial that was done, was looking at the mode of action on tar spot severity and grain yield. They found that 2 modes of action and 3 modes of action were better at controlling the disease and protecting or reducing severity. They also found that 2 modes of action and 3 modes of action slightly increased yield or protected yield from disease. So those are some different things to think about. Again, I don't know if or when we may need to be making fungicide applications for tar spot, but there is a lot of information out there to pull from if we arrive at that point. Fungicide timing was also evaluated, and the best timings you can see they're marked was VT, V6 plus VT, and R2. So they have already established timings. Again, that could be slightly different here in South Dakota, but we do have a baseline to start from if we need that. As tar spot is emerging in South Dakota, we have a lot of unknowns, if you couldn't tell from my earlier talks. We are scouting fields in all corn growing counties in South Dakota. We are looking at alternate weedy host for the disease, so looking at other grasses that might host the disease. We're currently working as part of a multi-state group with Kansas and Nebraska to explore the genetic diversity of tar spots. So we're looking to see, is the tar spot that's in South Dakota and Nebraska, Kansas, so the Great Plains region, different or the same as the tar spot that is in Indiana and Illinois? We're also working with Nebraska to examine the impacts of irrigation on tar spot in the Great Plains, and also trying to use all of this information that we're collecting to present at extension events. Now we're moving into bacterial leaf streak on corn. This is a disease that you might have heard about. You very well probably heard about it from Emmanuel Biomakama, who was in my position up until last year. So bacterial leaf streak, as it suggests, is a bacterial disease. It's caused by Xanthomonas vasicola, so it's a Xanthomonas species. The bacteria does overwinter in infested crop debris and might also occasionally be transmitted on corn seed. The bacteria enters corn leaves through natural openings and through wounds. So if you have a hail event or a windstorm, this could be a disease that gets a foothold in after those. Disease development is favored by high humidity, continuous corn, minimum tillage, as well as just having warmer summers in general. That it really encourages the bacteria to thrive. On the left side of the screen, you can see kind of a extreme example of BLS, the yellow streaks going parallel with the leaf midrib. The shininess that you can see on there is bacterial ooze, which will occur whenever the humidity is high. So these are all symptoms that we'll see. Also, if you've heard of BLS in wheat, this is a similar disease and it has similar infection cycles and symptoms. So symptoms start as narrow, long, light brown streaks. They expand to large, long brown streaks with wavy margins. And wavy margins is important because there are other diseases such as gray leaf spot that mimic bacterial leaf streak, but the margins are not wavy, they're more straight and square. You'll actually see yellow halos around the streaks when it's held up to light, which is what you can see in this left picture. The yellow halos is actually the toxin that the bacteria releases into the leaf, and it causes cell death. So that's what you're actually seeing. The disease does not appear to be systemic, and it rarely causes plant death. So it is one that can impact yield, but it doesn't always cause plant death. Here in South Dakota in 2023, because we were scouting for tar spot, we also scouted for a lot of other corn diseases, and BLS was obviously one that we were looking for. We did see it in at least 10 different counties, especially in the southern part of South Dakota. So it is widespread, but it was never in high amounts where it was impacting yields or causing detrimental issues on plants. And as this says, the impact on yield depends on the extent and the timing of infection. Most BLS infection happens later in the growing season, so it can't actually cause problems. Ways to manage the disease is through crop rotation. Non-host crops, basically anything that's not corn, will help break the disease cycle. They have found multiple times that BLS, it does grow on volunteer corn. So it's important to rogue out volunteer corn if you are in a bean or a wheat rotation. That way you are making sure that that disease cycle is broken. Tillage, when practical, I know many corn growers are no-till. Belling of stalks to reduce your corn residue in extremely positive fields is another option to help reduce that disease level. There is no complete resistance available in hybrids yet. There are several that have been suggested to be tolerant to BLS, so that would be something to investigate if you suspect you're having high BLS issues. And like I mentioned earlier, I have my grad student, Sierra, who is doing BLS research. So while BLS is not a major pathogen in South Dakota, it does have an impact on yields if the disease amount gets up to above threshold levels. So some research that we have ongoing in South Dakota is isolation of the BLS pathogen from multiple fields in both South Dakota and Nebraska to look at the genetics. And that's what you can actually see in the picture on the right side of the screen. That was some BLS that we pulled out from a county in Nebraska. The other thing that we're looking at is antagonist to BLS from soil. This is a similar project to what we just finished up doing in wheat. And we did find some promising and potential antagonist in wheat. So we're going to kind of complement that here in corn. And since I have a few minutes left, I'm just going to also briefly talk about our plant diagnostic clinic. I serve as the director of the plant diagnostic clinic. Many of you may know Connie Tandy, who serves as our diagnostician. So one thing to keep in mind is we are the only plant diagnostic clinic in South Dakota. So if you've had plant disease issues, please reach out to us. We're part of the Great Plains the Great Plains Diagnostic Network, and you can see there on the left side of the screen the states that are in our diagnostic network. We're grouped into these regions because we all have similar crops and similar disease issues. Why utilize the diagnostic clinic? We provide accurate disease diagnosis so you know what diseases you're dealing with, and that can help inform management decisions. And kind of that second point is to gain a better understanding of your disease management options. It also allows scientists such as me and other plant pathologists to better track the movement of diseases across South Dakota so that we can better curtail our research to what is being a problematic pathogen in the state. I'll leave this up for just a second. These are the contact information for myself and Connie Tandy. We did move to a new building this summer of 2023. So if you've been to the clinic in plant science, that has actually been closed down, and we are now in 203 Berg or Ag Hall. So please come visit us if you're on campus. And then just a final slide. If you would like to help with research in 2024, we have tons of disease surveys and disease research that we have going across the state. This is a list, again, of interest to us is corn and wheat BLS and corn tar spot. But if any of these apply to you or you're interested in working with us, please reach out to me, or Connie can get you in contact with me to participate. Here's some resources. The Crop Protection Network, I highly recommend if you have general disease questions. Obviously, our SDSU extension fact sheets, Connie and I are working to update a lot of those. I do know that many of them are very much out of date. And then the UNL Crop Watch publications are also a great resource. Mandatory slides. And then here's my contact information. I'll leave that up for just a second. I actually did not get my office number updated on here. Sorry. I'm in Berg 261. I also moved a floor down like Adam did this last summer. And then here's Connie's contact information if anyone needs it. And that is the end of my talk.
Okay, thank you, Dr. Shires. Are there any questions? There's nothing in the chat right now. All right, if there's nothing, I hope to see you guys again tomorrow. Tomorrow, I believe, is Dr. Jason Clark and myself that'll be talking. So thanks for attending.